Everybody in today's video, and in this video we'll practice some sample problems on balancing chemical equation. So let's get started. So this is our first problem. Balance the equation. So if you look carefully, you will see that this equation, balancing the equation, will not be very hard to you if you know the very basic of balancing an equation. So we can easily solve it with very basic knowledge. So let's do it. So at first we'll calculate the number of atoms in each side. So in the left side or in the reactant side, we have one mercury atom, and on the product side we have one mercury atom too. But on the reactant side we have one oxygen atom, and in the product side we have two oxygen atoms. That means the number of oxygen atoms are not equal or same. So we have to balance the number of oxygen atoms on each side. So as the number of oxygen atoms on the product side is double or twice than the reactant side, we can easily solve this by putting a 2 here. That means multiplying the number of oxygen molecules with 2. So now there are 1 multiplied by 2 oxygen atoms on this side, and that is equal to the number of oxygen atoms on this side, that means in the product side. So the number of oxygen atoms are not same. But if you look carefully, when we are multiplying the whole compound AgO, the number of mercury atoms are also increasing. So we have to balance the number of mercury atoms now. Now there are 1 times 2 mercury atoms, and in the side we have 1 mercury atom. We can easily solve this by putting a 2 here. That means 1 times 2 mercury atoms on the product side too. That means the equation should be balanced now. There are 2 mercury atoms here and 2 mercury atoms on this side too. We have 2 oxygen atoms here and 2 oxygen atoms here too. So the equation is now balanced. And when we will write down this will look like this. 2AgO is 2Ag. Here Ag means mercury plus O2. And this is the balanced version of the equation. Is busy, right? So this is our second problem. Here we are asked to balance the equation. So at first let's calculate the number of atoms. We have one tin atom here and one tin atom here too. We have 2 oxygen atoms here, but only 1 oxygen atom here. That means the number of oxygen atoms are not equal or same. We have 2 hydrogen atoms here and 2 hydrogen atoms here too. That means the tin atoms and hydrogen atoms are equal on both sides, but the oxygen atoms are not equal. So we have to balance the number of oxygen atoms. So if you look carefully, the number of oxygen atoms here is twice than here. So we can easily solve this. As here are 2 oxygen atoms, we can make 2 oxygen atoms here by easily putting a 2. That means 1 times 2 oxygen atoms here. That means the number of oxygen atoms here and here are now same, right? But if you look carefully, just like before, as we have to multiply the whole compound H2O or water, the number of hydrogen atoms are also increasing. So now there are 2 times 2, 4 hydrogen atoms here, and in this side we have 2 hydrogen atoms. That means twice than here. So we can easily solve this by putting a 2 on this side. That means 2 times 2, 4 hydrogen atoms here. And at last, let's check if the equation is now balanced. We have one tin atom and one tin atom here too. We have 2 oxygen atoms and 2 oxygen atoms here too. We have 4 hydrogen atoms and 4 hydrogen atoms here too. That means the whole equation is now balanced. Why? Because the number of atoms on each side are balanced. So, if we write down the equation now, it will work like this. Plus 2H2, that is hydrogen, is here S means tin, plus 2H2O, and this is the balanced version of the equation. So let's continue. So this is our problem 3, and here we ask to balance the equation. So this is a little bit harder than before, you will see. So let's continue. At first we will calculate the number of atoms on each side, just like before. So we have 2 nitrogen atoms and 1 nitrogen atom here. We have 4 hydrogen atoms here, but 2 hydrogen atoms here. We have 2 oxygen atoms here, and we have on this side 2 plus 1, 3 oxygen atoms here on the product side. That means none of the atoms are equal on each side. We have to balance all of them. So this is not a matter. We can easily solve this by following the easy steps. So at first, let's look at the nitrogen atoms. We have 2 nitrogen atoms here, but only 1 nitrogen atoms on this side. We can easily solve this by putting a 2 here, like before. And when we will put a 2 here, there will be 1 times 2 nitrogen atoms on the product side. That is equal to this. But when we are multiplying the whole compound nitrogen oxide, NO2, and that is a problem. Why? Because when I'm putting a 2 before this, the number of oxygen atoms are also increasing. So there are 4 oxygen atoms here, and on the product side there will be total 5 oxygen atoms, because 4 here and 1 oxygen atom here, that means 5 oxygen atoms in total. So we have to now balance the number of oxygen atoms. But here is a problem. We have now 5 oxygen atoms, and here we have 2 oxygen atoms. If we put a 2 here, there will be 2 times 2, 4 oxygen atoms. That is not equal to this. And if we put 3 here, that will be 3 times 2, 6 oxygen atoms on the reactant side. That is not also equal to the number of oxygen atoms on the product side. That means we have to balance it. To balance it, we have to now skip this step, as we cannot keep not a full number or not a real number here, 2 or 3, that is a real number. But if we have to put 2.5 or 2 point something, that will be not correct, and for that we have to now skip this step. We will continue to the next atom, hydrogen. So here we have 4 hydrogen, and in this product side we have 2 hydrogen. So we can easily solve this by putting 2 here. That will be 2 times 2, 4 oxygen atoms on the product side. That will be equal to the reactant side. But when we are putting a 2, we are multiplying the whole compound H2O. That means the number of oxygen atoms here is now 1 times 2 oxygen atoms. Wait. We had 4 oxygen atoms here, and now here are 2 oxygen atoms, that is 6 oxygen atoms in total. And to balance the number of oxygen atoms on each side, we can now do something. We can put a 3 here, and then the number of oxygen atoms will be 3 times 2, 6. And here we had 6 oxygen atoms, and now we have 6 oxygen atoms on the reactant side too. That means we have balanced the whole equation. Why? We had 1 nitrogen atoms here, sorry, 2 nitrogen atoms here, and here we have 2 nitrogen atoms too. We had 4 hydrogen atoms here, and here we have 4 hydrogen atoms too. We have 6 oxygen atoms here, and here we have 2 times 2, 4, plus 2 times 1, 2, 4 plus 2, 6 oxygen atoms on the product side too. That means all the number of atoms are now same on each side. That means the equation is now balanced. And if we write down this will look like this. And this is plus 2H2O. And this is the balanced version of the equation. Our fourth problem: balance the equation. So this seems to be a little bit harder than before, and this is really a little bit harder than before. Here we can see the new thing, that is hydroxide. But this is same, the steps are same as before. We have to at first calculate the number of atoms on each side. So we have 3 barium atoms here, and here we have 1 barium atom. We have 2 nitrogen atoms here, and in this side we have 1 nitrogen atom. We have 2 hydrogen atom here, but in this side we have 3 plus 2 hydrogen atom, that means 5 hydrogen atoms on the product side. Why we have make a summation of 3 plus 2, 3 and 2. This is for the hydroxide. Here is a 2 after hydroxide, that means multiplying 2 with each of the atoms inside. So we have to multiply H, that means 1 atom, with 2, that means 2 times 1, 2 hydrogen atoms. So we have on this side 3 plus 2, 5 hydrogen atoms, and here we have 2 hydrogen atoms. So in the reactant side we have 1 oxygen atom, and in this side we have 2 times 1, 2 oxygen atom. And means none of the atoms are equal on each side, so you have to balance them all. So at first let's look at the hydrogen atoms at the hydroxide. As there are hydrogen and oxygen in the hydroxide, we'll at first look at the hydrogen and oxygen atoms. And on the reactant side we have hydrogen and oxygen in the H2O or water. That means we have to at first look at the H2O, and that means hydrogen and oxygen atoms. So we have 2 oxygen atoms here, and here we have 5 hydrogen, we have 2 hydrogen atoms here, and on the product side we have 5 hydrogen atoms. So this cannot be balanced. We cannot make 5 by multiplying 2 with a full number. So we can now dive to the oxygen atom. We will skip the hydrogen atoms for now. So we have 1 oxygen atom, and here we have 2 oxygen atoms, right? So as we have twice of the oxygen atoms on the reactant side, we have one oxygen atom on the reactant side and two oxygen atoms in the product side. We can easily balance this by putting a 2 here. That means multiplying the number of oxygen with 2, and now we have 2 oxygen atoms in the reactant side, that is equal to the number of oxygen atoms on the product side. So when we are multiplying the whole compound H2O, the number of hydrogen atoms are also increasing. That means there are 2 times 2 for hydrogen atoms on the reactant side. And let's check it now. We have 2 times 1, 2 plus 3, 5 hydrogen atoms on this side. And now we have 4 hydrogen atoms on the reactant side. And we can till now cannot solve this or cannot balance this by multiplying something with the number of hydrogen atoms. So we will skip the number of we skip this for now too. So let's look at the number of barium atoms. We have 3 barium atoms here and 1 barium atom here. We can easily solve this by putting a 3. That means 3 times 1, 3 barium atoms in this side. That is equal to this. But when we are putting a 3, something interesting is happening. We are multiplying the whole compound, right? So the number of hydrogen and oxygen atoms are also increasing. So we had 2 oxygen atoms here, and when we have put a 3, there are 3 times 2, 6 oxygen atoms. So we have 2 oxygen atoms on the reactant side and 6 oxygen atoms on the product side. Now we have to change the number 2. We have to put a 3 here, right? So when we'll put a 3, we have not to put a 3, we have to put a 6, right? That means 6H2O, and then we will have 6 oxygen atoms, and that will be equal to the product side, 3 times 2, 6 oxygen atoms. And again we had 2 hydrogen atoms, and now we'll have 2 times 3, 6 hydrogen atoms. And this is not a matter. We had 6 times 2, 12 hydrogen atoms on the reactant side. And wait, there is not only 6 hydrogen atoms, that means 2 times 3, 6 hydrogen atoms. Don't forget to make a summation of this. That means there are not only 6 hydrogen atoms, there are 6 plus 3, 9 hydrogen atoms now, and we have to balance it too. So don't forget to sum all the atoms. But there is a problem. We cannot till balance them. We have 12 hydrogen atoms on the reactant side and 9 hydrogen atoms on the product side. This cannot be balanced. So let's check the number of nitrogen atoms. We have 2 nitrogen atoms here on the reactant side, but only 1 nitrogen atom. We can solve this by putting a 2 here. That means 2 times 1, 2 nitrogen atoms on this side. That will be equal to the reactant side. And I think now we have come to a result. When we are putting a 2, that means multiplying the whole NH3 compound, there will be 3 times 2, 6 hydrogen atoms. And this is now on the product side. We have 3 times 2, 6 hydrogen atoms plus 6 hydrogen atoms, 12 hydrogen atoms in total. That means the whole equation is now balanced. Why? We had 3 barium atoms and 3 barium atoms here 2. We had 2 nitrogen atoms and 2 nitrogen atoms here 2. We had 6 times 2 12 hydrogen atoms on the reactant side, and in the side 3 times to 6 plus 3 times to 6, that means 12 hydrogen atoms on the product side 2. And we had 3 times 1, 3 oxygen atoms on the reactant side, and in the side we had 6 times 1, 6 oxygen atoms, and in this side we had 3 times 2, 6 oxygen atoms on the product side 2. That means when I will write down this clearly, this will look like this. Here will be 6H2O, that is and this is the balanced version of the equation. Look to this and again solve this in your brain, and that will make you professional in balancing chemical equations. In this video we have solved or balanced 4 equations, and we have gone step by step. So this, I hope this will help you in your study or learning balancing chemical equations. And in the next videos, in the future videos, I will discuss on some harder problems and some different types of equations. So thanks for watching. I will hope you will like and share and subscribe my channel. If you like this video, please put a comment. This will help me a lot.